Hello students, welcome to Saurav Sir's classes. Today we are going to discuss about the topic sequence and series. Okay, you can already see the name of the topic is written on top, sequence and series. Yeah. Okay, so let's go on to the second slide and understand what is a sequence. Any ordered pair, okay, any ordered pair of real numbers, let's say a1, a2, a3 right on till an is called a sequence. Okay, and it is denoted by an. It is denoted by like this an, or it is denoted by an, or it is denoted by an this way. They are all sequences. They are all sequences. Okay, arrow marking on to the sequences. Okay, so if the number of terms is unlimited, then the sequence is said to be an infinite sequence. That means if the number of terms are limited, then the sequence is a finite sequence, right? So in an infinite sequence, what happens? The number of terms will continue. Okay, the number of terms will continue. You can see over here 1, 3, you can see 1, 3, 5, 7 and so on, continue to right until the nth term, and then from here it's again continuing. So how did they get the nth term? Very simple. How they have got the nth term? So look very carefully. So Tn, okay, this is how they have got the nth term. Alright, so this, you know, it's an AP. This is the term that is given over here. The things that are, the numbers that are going on over here is an AP. Okay, so how do you find out the nth term of an AP? It's given as Tn, okay, Tn or An is equal to A plus n minus 1 D. So here Tn will be equals to A is the first term, so first term is 1 plus n I don't have, n minus 1, common difference will be 2. How 2? So if you will do 3 minus 1, you're going to get 2. Then you do 5 minus 3, you're going to get 2, and so on. Okay. So from here what do we get? Tn, we get 2n minus 1. So you can check it out. Multiply that out and you get 2n minus 1. So this type of a sequence which will continue is called an infinite sequence. Alright. Okay. Now let's go on to our next slide. Let us analyze this sequence as well. So you can see this sequence is also an infinite sequence. Why? Because from here you can see these dots continuing. So these dots means this sequence will continue right until infinity. Now look at this sequence. This sequence is, let's say, an is equal to minus 1 n minus 1. Okay, so this type of sequence will oscillate. Sometimes it will give you minus 1, then sometimes give you 1, again it will give you minus 1, again it will give you 1. But that's not the basic point over here. Okay, oscillatory or not oscillatory. We are talking about infinite sequence. No matter minus 1, 1, minus 1, 1, it will still continue until infinity. Okay, understanding? I hope you all are understanding. Let's go on and understand limit of a sequence. A sequence is said to tend to a limit L, okay, if for every epsilon greater than 0, we have to take an epsilon greater than 0, a value n we have to take of small n can be found such that an minus L, an minus that limit will be less than the epsilon that you had chosen, and of course the small n will have to be greater than equal to the large n, and yes, n comma capital N both will belong to natural number. So in simple words, how you can write? You can write limit of x tends to infinity, an tends to limit, or simply as an tends to L, n tends to infinity. Alright, nice. Now we have to continue on to our next slide. Okay, convergent sequence. What is a convergent sequence? how do we know that a sequence converges? Let's see. If a sequence an has a finite limit, it is called a convergent sequence. Let's give you an example. Let's say I take an is equal to 1 by n, and I keep putting the values of n. So when you put 1, then you'll get 1. When you put 2, you get 1 by 2. When you put 3, you'll get 1 by 3. When you put 4, you'll get 1 by 4. When you put 5, you'll get 1 by 5. So you can see this sequence is converging to 0, right? So it will continue as you increase the denominator. As you increase the denominator, the sequence will get divided. The 1 will get divided and get closer and closer to 0. Okay. So if a or n is not convergent, it has to be divergent. So if it is not convergent, then it is a divergent sequence. So in the above example, 2 is in the above example means over here in this example, the second one is convergent. This one is convergent. Just hold on, I'll highlight it for you. This one is convergent. Alright, it's saying the second example is convergent, right? The second example, number 2 is convergent, while 1 and 3 not number 2. Oh, sorry, this is not convergent. It cannot be. That's what I was thinking. How is it? How are they saying that this is convergent? Because I just now said this is an oscillatory function. So it will not converge to anything because it is becoming sometimes -1, then sometimes 1, then -1. They were telling about part 2, okay, and I was looking at part 3. So this is the part 2, and definitely this is convergent. Just now I showed you, this is the example they are talking about. So the example is here itself. You don't have to see from there. Okay, so this sequence is convergent. Okay, but the part 1 and part 3 are divergent. So that means an, which is equal to 2n minus 1, is divergent. Okay, and xn, suppose, which is equal to -1, okay, n minus 1. So this is also divergent. Although this is an oscillatory function, okay, it is oscillating between two values, so it is neither divergent nor convergent. But I don't know why they have written it divergent. Okay, but not to worry. You have to understand that this sequence will neither converge nor diverge. It will keep oscillating between -1, 1, again -1, again 1, again -1. So as you start putting the value of n, when you put n equal to 1, then you're getting power as 0. So then you're getting 1. When you put n equal to 2, then you're getting 2 minus 1, that is 1, that is -1. Then again 1, again -1, and so on. Okay, let's go on to the next part. Bounded sequence. Now we are going to talk about bounded sequence. What is a bounded sequence? A sequence an is said to be bounded if there exists a number k such that the an is less than k for every n. Okay, so bounded means what? The an will have to be less than k or greater than k. Okay, the an has to be less than k or greater than k. Okay, then it is called a bounded sequence, because bounded sequence, it's bounded above or below. Okay, you need to understand there are two bounds. One is bounded above and one is bounded below. So you will have basically two parts over here, less than or greater than k. Okay, so just for bounded sequence, here you just write an is less than k. Now, monotonic sequence. What is a monotonic sequence? If a sequence is increasing, decreasing, strictly increasing, strictly decreasing, then that type of a sequence is called a monotonic sequence. So if a sequence is increasing, decreasing, just hold on. Okay, so if the sequence AN is said to increase steadily or decrease steadily according as this happens. AN plus 1 is greater than equal to AN, or AN plus 1 is less than equal to AN for all n. Alright, for all values of n. Okay, so very simple concept, nothing so difficult. Okay, now let's go ahead and understand the next slide. And in this part, of course, the n that you have will belong to all natural numbers. Okay, all natural numbers. Hold on. Okay, now it's fine. Yeah, so the n will belong to all natural numbers. Okay, let's go on to our next. Both increasing, it says, both increasing and decreasing sequences are called monotonic sequences. Okay, monotonic sequences always tend to a limit. This is written as a limit. Okay, a limit, finite or infinite. Thus a sequence which is monotonic and bounded is convergent. So a sequence that is monotonic and bounded is convergent. Alright, let's go on to our next part. Next is the series. So how do we understand, how do we differentiate between a sequence and a series? You see, a series is written in this way with addition, while a sequence is just written with commas. Okay, alright, so this type of writing right until infinity is called an infinite series. An infinite series is denoted by summation of un, and the sum of the first n terms is denoted by Sn. Simple concept. Alright, very simple concept. So you will have all the different terms, right? You will get all the different terms. Say T1, then you will have to add the second term T2, plus then T3, plus then T4, plus and so on. Alright. Okay. This is the next one. Convergence. The next one would be convergence, divergence, oscillation of series. So convergent, divergent, as well as oscillating. How I taught you, I just showed you how an oscillating series is, oscillating between 2 points, 1 minus 1. Yeah. So what does it say? Consider the infinite series un, summation un. Okay, which is u1 plus u2 plus u3 right until infinity, and let the sum of n terms be Sn, which will be u1 plus u2 plus u3 right until un. Clearly Sn is a function of n, and as n increases infinitely, the three possibilities arise. So if n is increasing infinitely, if n is increasing indefinitely, okay, indefinite increase, then three possibilities will arise. And what are the three possibilities? These are the three possibilities. First one, if Sn tends to a finite limit as n tends to infinity, the series un is said to be convergent. So if Sn tends to a limit L as limit n tends to infinity, then what happens? The series un is said to be convergent. Next point, make sure you mark these as important points. These are few important points that you should know. If Sn tends to plus infinity or minus infinity as n tends to infinity, then the series un is said to be divergent. Okay, what is happening now? The Sn is tending to infinity. Over here the Sn was tending to some limit point L, correct? But over here the Sn is tending to infinity. That means this is divergent, correct? Let's understand this. If Sn does not tend to a unique limit as n tends to infinity, then the series Un is said to be oscillatory or non-convergent. So if Sn does not tend to a unique limit, okay, as n tends to infinity, even if you are writing like this, like limit n tends to infinity Sn, it's not tending to some limit L, that's wrong, and it is also not tending, that's wrong, to infinity. So if it is not tending to both of them, okay, then what is happening? It is oscillatory, it's oscillating, or it is non-convergent. Oscillating, how? Like An, I showed you, it's oscillating. Minus, you can take a simple example, minus 1 to the power n. So this type of a sequence is oscillating, okay, oscillating between 2 points. Alright, so today in this part of the video we have learned 3 things. We started with sequence and series, we learned what a sequence is, and I showed you how you can what is an infinite sequence and how you can get 2n minus 1 for this example, okay, although you know that. Alright, let's go on to the next slide. Then convergence of the sequence, how a sequence is convergent and how a sequence is divergent. Alright, now above or below, bounded above, bounded below, a sequence is bounded, okay. So if a sequence is bounded below, then it will be given greater than equal to, and if it's bounded above, then it will be given less than equal to. So you know how it will be. Now the monotonic sequence, in the monotonic sequence you can see easily what is a monotonic sequence. A sequence that is increasing or decreasing. What is it? It increases or steadily decreases, then it is called a monotonic sequence for all values of n, and of course n belongs to natural number. It's written over here clearly, both increasing and decreasing sequences are called monotonic sequences, okay. Next point, series. Simple, a series is just written with addition sign. Here you can see same thing, the terms are written by adding them together. Alright, that's the definition for series. Then second one is convergent, divergent and oscillatory series. Alright, and the limit, how Sn is tending to a finite point, okay, you can see Sn is tending to a finite point as n is tending to infinity, then it is a convergent sequence. Sn is tending to plus infinity or minus infinity as n is tending to infinity, then it is a divergent sequence. And Sn is not tending to any limit point, that means it's getting two points that is fluctuating, or different points are coming, and no limit point is coming, then that type of a function, that type of a sequence is oscillatory and it is not convergent. Alright, this not convergent. Okay, so anyways, that's it for this video. We will continue with this sequence and series in the next video. So keep taking as much help as possible, because all the help that you need will be provided at Saurabh Sir's classes. Thank you for watching.